you're going to work with angles of rotation, and I want you to be able to draw angles in standard position and to determine the values of the trigonometric functions for an angle in standard position. So in section 13.1, you worked with trigonometric functions using acute, so angles that were between 0 and 90 in right triangles. In section 13.2, you will be using other types of angles as well. Now, let's just go over what standard position means. That's very important you understand what that means. Standard position is when the vertex of the angle is at 0, 0, or the origin, and one ray is on the positive x-axis. So if you're looking at the coordinate plane, one side of the angle has to be on this axis right here. Now, the initial side is the ray or the side of the angle that's on the x-axis. So that would be, this would be the initial side, and then the terminal side would be the other ray. So anywhere it would be, it could be here, 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 and so on. Now, the angle of rotation is formed by rotating the terminal side and keeping the initial side in place on the x-axis. So let's just think of having a ray right here. We're going to leave the ray here. We'll move the other another ray either this way or this way to form an angle. The one that stays on the x-axis is the initial ray, and the one that moves is the terminal ray. Okay, if the terminal side is rotated counterclockwise, now think of a clock. Counterclockwise would be this way. The angle of rotation is positive. So that's how you tell whether you have a positive or negative rotation. If the terminal, this should say terminal side, not clockwise. If the terminal side is rotated clockwise, so again, think of a clock. If we rotate the angle this way, then it's called a negative rotation. So kind of think of, as you're going up this way, you're going towards a positive direction of y. Going this way, you're going to the negative direction. So if it goes this way, it's a positive rotation. This way, a negative rotation. Now, the terminal side can be rotated more than 360 degrees. So let's look at some diagrams here. This is your initial side, and this is your initial side, always on the positive x-axis. The terminal side is after you rotate it where the ray stops. So here, since we're going up from the x-axis, it's going to be a positive 135. And here, this is the initial side on the x-axis, so we're measuring it from there, and we're going down, so that would be negative. And this is the terminal side. So clockwise is this way, counterclockwise is this way. Counterclockwise is negative. Now, from last year in geometry, 360-degree rotation is a complete circle or a complete rotation. 180 degrees would be half of a complete rotation. Okay, now it's important that you're able to draw angles in standard position. So we want to draw an angle with the given measurement in standard position. So if you look at these, this one is to rotate the terminal side 360. Now this is positive, so that means we have to go this way in the positive direction. So we would go all the way around here. Remember, 360 is the whole thing, so we would stop here and draw the terminal side. This is negative 150, so that means we have to start going down. We don't want to go this way, we want to go this way. So this would be 90 degrees, and then we would go another 60 degrees and draw the terminal side. Initial side is on the x-axis, here, here, and here. Now this one says 900, so that is going to go clockwise. So again, we're going to go up this way, and we keep circling around. We're going to go around once for 360, another time for 720, another time till we get to 180 here, and that will give us 900 degrees. Okay, so I just want to repeat again that when you talk about standard position, the angle has its vertex at the origin, which is 0, 0, and one ray on the positive x-axis. So they all have a ray on the positive x-axis. All right, now, those are standard positions. Now we want to talk about coterminal angles. And a coterminal angle, their angle, or I have angles here, I guess, so their angles in standard position with the same terminal side. So they share not an initial side, but a terminal side. So if you look to the diagram at the right here, you can see that this is positive 120 because it's going up. This is negative 240. They share this same side. So this is the terminal side that they share. Now, there are an infinite number of coterminal angles, and one way you can find the measure of an angle that's coterminal with an angle is to add or subtract integer multiples of 360 degrees. So let's look at a couple of examples. We want to draw an angle with these given measurements. Okay, so when we draw this, we need to start out on the positive x-axis, and then I'm going to, since this is positive, it's 320 degrees. Now remember, 360 is all the way around. So we're going to go, there's 180, 270, and we don't want to go all the way to 360, so we'll just kind of put it right here and draw our angle. So it has its vertex at the origin. This is its initial side, go all the way around, and this is its terminal side. Okay, now we're going to go to the negative 110. Now remember, when it's negative, we go in the negative direction. So if we start here, it has to start on the positive x-axis. This would give us 90 degrees, and then we're going to go just a little bit further past 90 to make 110. So again, the angle, this is the initial side, we're rotating, and this is going to be negative 110. We want to go down for this one. Okay, now this one is positive 990. So we're going to start on the positive x-axis, and we're going to go around once for 360, twice for 720, and then when we add 180, that's going to get us to 900. And then we'll go 90 more degrees, and that is going to give us 990 degrees. I'm just going to put a little arrow here. Okay, now we want to find measures of a positive angle and a negative angle that are coterminal. Now remember, those have the same initial side, and they share a terminal side. But let's see what's going on here. We want 65 degrees, so we're going to, and remember, you can do multiples of 360. So, and there's an infinite number of angles that could be coterminal. So we'll start with 65, and I'm just going to add, so we're going to write theta first, so theta is 65. 65 plus 360 is going to give us 425. And then I'm going to take 65 minus 360, and that'll be a negative 295. So I have a positive and a negative angle. Now, when I get to an angle that is larger than 360, what happens, I'm going to do 410, and I will add 360. So that's going to give me 770. And now when I subtract 360, I end up with 50 degrees. So I have a positive angle and a positive angle. This one's not negative. So what I need to do is subtract 360 again. And now I have negative 310. So here you want a positive coterminal angle and a negative. So positive and a negative coterminal. All right, next thing we're going to do is find the measure of reference angles. And a reference angle is a positive acute angle formed, and remember, this is acute, so it has to be in between 0 and 90. It's an angle formed by the terminal side of theta and the x-axis. Now, this doesn't say positive x-axis, it just says x-axis. You're going to be using reference angles to find trigonometric values of angles whose measures are greater than 90 degrees or less than 0. So you're going to be in the first quadrant. All right, we want to find the measure of reference angles. Okay, when I said first quadrant, I just want to show you here that your quadrants are listed numbered 1, 2, 3, 4, Roman numerals, and they're going clockwise. Okay, so we want oops, here we go. 150 degrees starts at the initial side. It's positive, so it goes this way. And there is the terminal side. And now we want to go from the x-axis to the terminal side. Well, all the way around would be 180. So 180 minus 30 is going to give you, or sorry, 180 minus 150 is going to give you 30, which is your reference angle. Now we're going to go negative 130, so that means we're going to go down. So here is the drawing of your arrow. Here's negative 130, and we need to go to the x-axis. Again, it's not the positive x-axis, it's the x-axis. So, and it has to be a positive reference angle. So this whole thing is 180. So that means we have 50 degrees back from here. 180 minus 130 would give us 50 degrees. And now we have 280, so it's positive. We're going to start here, go around this way, and we're stopping here. And so we know that we have 180 from here to here, so that means we have an additional 100 degrees right here. So this is going to be, I'm just going to go like this, is 180 degrees. So that means from here to here, it's 100 degrees. So what we have left is this, for this reference angle, is 80 degrees. Now, I'm going to repeat again. Notice the sign of the reference angles. They are all positive, and that one side of the angle is always on the x-axis. Okay. Going to measure to find the reference, or find the measure of the reference angle for each given side. Sometimes it's helpful to sketch the angle. So we have 135, and what I did, this is your angle. And we want to find the reference angle here. So we're just going to take 180 minus 35, and that's going to give us 45 degrees. So we're looking for this one right here. Okay, negative 105. So we're going to go this way, down, draw the terminal side, and then it needs to meet the x-axis. So basically this is 180 minus 105, and that's going to give you 75 degrees. Okay, now 325. It's positive, so we're going up and around. And remember, the whole thing is 360, so we can take 360 minus 325, so that is 35 degrees. All right, last thing that we're going to do is trigonometric functions. And what's going to happen is you are going to be given a point, and you're going to be asked to find the 6 trig functions. So first thing, this diagram will help you know the location of different things here. You're going to be given a point. You're going to drop a perpendicular segment down to the x-axis, and the radius we're just going to label as r, so think of that as the radius. And we have a length x here and a length y here. So we're actually, if you're thinking of a circle, this would be the radius. As we're talking about trig functions, we just say r. Okay, so looking at this drawing, the sign is always the opposite. Well, y is the opposite side from this angle. So it would be opposite over the hypotenuse, so that's why the sine of theta is y over r. The cosine is the adjacent over the hypotenuse, and the tangent is the opposite over the adjacent. All right, so the first thing that you need to do when we're given a point, negative 6, 9, we're going to do a quick sketch, and the terminal side goes through point negative 6, 9, and we want to find all 6 trigonometric functions for theta. Okay, so very first thing, plot the point, so it's negative 6, 9, and use it to sketch the graph with the angle in standard position. Now, standard position means that its vertex is at the origin, and its initial side is on the positive x-axis. Okay, so the initial side is right here, and then the point negative 6, 9 is here. So what I'm going to do is go through here, draw a point from the origin to the given point, I'm going to make a triangle out of it so I can use my trig function. So I'm going to drop a line down here, and now I'm going to label my sides. From the origin to the corner or the vertex of the triangle here is -6, and then the length from the point down to the x-axis is 9, so that's my y-coordinate. Okay, now for a right triangle, we just need to find this side right here, so we're going to use a squared plus b squared equals c squared, so that's how we find r. So r equals 6 squared plus 9 squared, and when we simplify that, we get the square root of 117. Now, there is a perfect square in 117, so whenever you get your square roots, you need to take, you need to simplify them. So if I would do a factor tree, this would be 3 times 3 times 13. So r is going to represent 3 times the square root of 13. Now, that is your hypotenuse. Okay, once you have that set up, you just need to find your trig functions. And I really didn't give you enough room, and I thought I could probably squeeze it on here, but you might not be able to tell what I'm writing. So I'm putting it on a separate sheet of paper so you can see it a little bit better. All right, and I probably still need the picture here, so let's just do this. I'll put this over here, just slide everything over a little bit. Okay, so sine of theta. I'm starting here, and I need the opposite, which is 9, over the hypotenuse, which I'm going to write in here 3 times the square root of 13. Okay, so it's 3 times the square root of 13 in the denominator. Now, from earlier in the year, we simplified, and we can't have square roots in the denominator. So we're going to multiply the numerator and the denominator by the square root of 13. And when I do that, I'm going to get 9 times the square root of 13. This is going to be 13, so it's 3 times 13. Now I can reduce. So I have 3 times the square root of 13 over 13. Okay, I want to keep my triangle here with my paper so we can keep looking back. Okay, now I need the cosine. So the cosine is the adjacent over the hypotenuse, so it's going to be -6 over 3 times the square root of 13. So -6 over 3 times the square root of 13. Same thing here. Multiply the numerator and the denominator by the square root of 13. That's going to give you -6 square root of 13 over 3 times 13. And then we can just reduce here, and that's going to give you -2 square root of 13 over 3. Now, the tangent is the opposite over the adjacent. So that's an easy one because there's no square roots in here. Opposite is 9 over -6, and then we can just reduce that and get -3 over 2. Okay, now the other 3 trig functions are just reciprocals of the sine, cosine, and tangent. So we've already solved them. We're just going to have to simplify. We'll take the reciprocal. So remember, there's always one c with each of these. Cotangent's an easy one to find, so you have secant and cosecant. Since secant, each one has to have a c, sine has to go with cosecant. All right, so remember that cosecant is the inverse of sine. So I just need to, I don't know if you can see all of it here. The sine was 3, sine of theta, was 3 times the square root of 13 over 13. So when we do the cosecant of theta, we're going to do 13 over 3 times the square root of 13. We just took the reciprocal of the sine of theta. And then we're going to do simplify, so square root of 13 over square root of 13. And then we can reduce here, and you end up with a square root of 13 over 3. All right, now the cosine, the secant theta is the inverse of cosine theta. So if we want the inverse, and let's just put thetas on here, we're going to look at what the cosine was, and that was -2 square root of 13 over 13. So we just take the reciprocal, and that is 13 over -2 times the square root of 13. So again, we have to simplify. Square root of 13 in the numerator and denominator, we multiply by that, and that's going to give us 13 square root of 13 over -2 times 13. And we can reduce here, and that will give us negative square root of 13 over 2, sorry. Okay, the cotangent is the reciprocal of the tangent, so we're just going to take this and flip-flop it, take the reciprocal of it, and it's -2/3, and that's already simplified. And there are your 6 trigonometric functions.